All right, so the first thing we need to clear up, there are more than one ways to measure angles. I know most of us, sorry, but when we're trying to measure angles, we grow up using what? Degrees, right? So you might see an angle is 30 degrees, you might see an angle is what? 60 degrees, okay? But there are other ways to measure angles, just like with length. There are different ways to measure length. You don't have to use centimeters. You could use inches. You could use kilometers. You could use miles. There are so many different ways to measure length. So, and of course, there are many ways to measure angles. The one you are accustomed to is degrees. That's this guy here. But there's another way to measure angles, and it's something called radians, right? So do not mix up the word radians with the word radius. Remember, the radius is part of a circle. Radians is a way to measure what? Angles. And there is, of course, if somebody gives you an angle in radians, there should be a way to convert it to degrees. And of course, if something is in degrees, there should be a way to convert it to radians. So on the screen here, right? This here is the formula to convert, like if I give you degrees, like how to convert it to radians. But you want to leave the answer in terms of pi. For example, and I'll explain the chart here in a little while, right? Let's say somebody gives you 60 degrees, okay? But you don't want to use degrees for whatever strange reason. You prefer to use what? Radians. To convert the degrees to radians, you just replace the word, well, I'm going to have to write the formula here, right? You're going to take pi on what? 180, and you just multiply it by 60 degrees. And leave your answer in terms of pi. If you try to simplify this, 60 into 60 is 1, 60 into 180 is 3. So you end up with pi divided by 3. You will notice I already have it laid out in the chart for you. 60 degrees is the same thing as what? Pi on 3, right? Of course, I could prove it for you for 30 degrees also. I could prove to you that 30 degrees is the same thing as pi on what? 6. If you use the formula here, if we take pi on 180 and multiply it by 30, the 0 and the 0 will cancel out. 3 into 3 is 1. 3 into 18 is 6. You get pi on 6. So the point of this table, which I want you to take down, is that these are very common values that you find in the CSEC exam. You have to know 0 degrees is the same thing as 0 radians. If you see pi on 4, you know that's the same thing as 45 degrees. If you see 3 pi on 4, it's the same thing as 135 degrees. It will do you really, really, really well if you can learn off this table by heart. It might be hard at first, but if we do enough questions, I bet you it sticks in your memory forever from now till, like with me, it stick with me from now since high school, it stick with me because I did so much questions from then to now. So I want everyone to take down the formulas here, like how to convert degrees to radians. And of course, if I give you radians, you could convert it back to degrees. And also take down the chart because I need you to learn it off by heart, okay? And I will help you remember it with a tremendous amount of examples. So let me know when you're finished with everything on the screen, and we will switch the slides. Just for recording purposes, I added in one more angle. 360 degrees is the same exact thing as 2 pi. So let's move to our first question today on trigs. So if this were a normal maths exam, right? And someone asked you to solve this, cos theta is equal to 0.76. Well, I know most people could do this. If you want to solve for theta, you just take what? Cosine and you throw it across. Remember in maths, when you throw anything across, it becomes what? The opposite. And the opposite of cos is what? Cos inverse or cos minus 1.76. So everyone typing this on the calculator, right? Let me see what you got. I have my calculator here as well. To get cos inverse, I have to press second function, cos 0.76. Now remember, my calculator is on degrees mode. And when I press equal, just ensure that you're seeing that. Of course, we're trying our best to go to 2 decimal places, right? Let's form that habit at least today. So if we round it off properly, you will get 40.54. Notice you have to add 1 to the 3, right? So let's just be as accurate as we can today. So make sure you physically see it on your calculator. Now, if this was a normal maths exam, right? If it were that, you would get it correct. But in AdMaths, whenever you solve for an angle, you usually don't get one answer. You, at least, well, in 99.9% of the cases, you're supposed to really get 2 answers. So I'm going to show you how to get that answer, the second answer. It takes a little bit of practice, right? Most people will not get this on the first try. It will take us about 10 tries, and then everyone will say, okay, finally, I understand it now. I need for you all to take down this chart here, exactly as how I have it, and take down this note. It will not make too much sense at the moment, but it's my job to explain it. So take a couple minutes, take it down, and then I will jump in to explain. So let's just look at the note in the box here. Let's read it through. At the point of throwing across sine, tan, or cosine, if the number is negative, we have to temporarily ignore the negative sign. Let's see if this note applies to today's question, because sometimes the note will apply and sometimes the note will not apply. So we have cosine. When we are throwing across the cosine, because this is the point in the question where we have to throw across the cosine, is the number on the other side negative? Let's just make sure. The number on the other side is what? Not negative, all right? This is clearly a positive number waiting on that side. So tell me something. Does this note apply today? Do we have to pay attention to the instructions in that green box? No. Great, right? So I just let you know that green box is going to be super important. Anytime it have a negative number waiting on this side, at the point of throwing across the trig, the sine, tan, or cosine, we will have to ignore the negative sign. But when it's positive, we don't have to worry. It's be like a normal question. Now, here's the thing. You will notice that the little chart here, the fancy looking chart, has 4 sections. 1, 2, 3, 4. You just actually read it anti-clockwise. You don't actually read it clockwise. And this is your starting point, right? Quadrant 1, quadrant 2, 3, and 4. In the first quadrant, everybody is positive. Sine is positive, tan is positive, and cosine is positive. In the second quadrant, only who is positive? Sine is positive. Now, I did write out the obvious, right? But I'm going to say it. If sine is positive, they're really trying to say cosine and tan is what? Negative. That is what it really means. And like in quadrant 3, if tan is positive, in this quadrant, only tan could be positive, which means by default, cosine is negative and sine is negative. And in quadrant 4, obviously, if only cosine is positive in that region, then it means the rest are what? Negative, right? Made a slight mistake there. The rest are negative, all right? So, but in most textbooks, right, they will not bother to write the ones in pink because it's kind of obvious. If 1 is positive, the mentioned one is positive, the rest will be what? Negative. But that's going to leave it here just for the time being, right? Of course, just how our first example, over here, sine is positive, cosine is positive, and tan is positive. Everybody's positive in quadrant one. So here's the thing now. You will see the letter alpha in all of the formulas, right? You'll see all of them have alpha. Alpha is the first answer you get when you throw across the sine, tan, or cosine. So this over here, the first answer is alpha. Who can tell me in which quadrants is cosine positive? Because this is a positive type of question involving who? Cosine. Which two quadrants, and it will always have two quadrants, which two quadrants is cosine positive? Right, it will be quadrant 1. Somebody said 2 and 4 by mistake. It's quadrant 1 and 4. Look at it. In quadrant 1, cosine is positive, and in quadrant 4, cosine is positive. So if your answer is in quadrant 1, alpha is one of the answers. So our first answer is 40.54, but we had that over here. To get our second answer, we have to use the formula in what? Quadrant 4. We just have to take 360 and minus what? Alpha. Alpha is the first answer we get. Minus this, and you'll get the second answer. So you can call the first answer theta 1, and you can call the next answer theta 2. Right? So minus it and let me know what you get on the chart there. 360 minus 40.54. It takes a little bit of practice, don't worry. We will get to the 319.46 degrees. Don't get worried. That's just the first example. We're going to have a ton of others. If you only understand this like 20% of what was just taught, that is good enough for the time being, right? I'll give you a few seconds. So that's question 1. Let's see what happened with question 2. Look at this question here. We have tan theta is equal to negative 0.45. So if we want to solve for theta, well, guess what? We have to throw across the tan, and we will get what? Tan inverse. But when the tan is flying across the equal sign, he says, uh-oh, wait, the number waiting on this side is negative. So does the box, the rule in the green box, does it apply now? What do you all think? Right. So the rule in the box applies. It's a strange rule. It comes like, well, why does the positive does not have a rule, and then the negative have a rule associated with it? Just accept it. All right. So when you're finding the first angle, remember the rule is saying when you're throwing across tan and it sees a negative, you just find tan inverse and you just ignore this negative sign. So you just type in tan inverse 0.45. You just type in that. You ignoring that negative sign. Let's see what you get. Right. Let me go to my calculator as well. Second function, tan positive 0.45. I'm ignoring that negative sign. And I'm getting 24.23. Yep, that is looking correct. 24.23. Now, you see the first answer you get. He is always alpha, right? You just call this the acute angle. Remember, an acute angle is an angle between 0 and 90 degrees, right? But the point is, the first answer you get, whether you use the box rule or not, is alpha. Now, we are just temporarily ignoring the negative sign. Remember we said that, right? Look at the words here. The question was a negative, but we just temporarily ignore the negative sign. which means at some point in time, we're going to have to pay attention to that negative sign. We can't ignore it forever. So now you ask yourself, what kind of question was this? Was this really a positive question or was this a negative question? And in reality, it was a negative question. And who was it involving? Tan. So go to the chart now. In which two regions is tan negative? Because this is really a negative tan question. Where's tan negative? Right, a lot of people, Jared, check it back. You can't say 3 because in quadrant 3, tan is positive. This is really a negative question. Tan is negative in the second region and the fourth region. Remember, if sine is positive, the other two are negative. If cos is positive, the other two are negative. For those who got it wrong, you understand it now? Right, okay, so some people said it was just a typo. All right, so do you think you could get the two answers for me? We're using the formulas in the second and third region. Just replace alpha with how much here? 24.23. And replace this alpha with what? 24.23. So the first answer is 180 minus 24.23. And the second answer is 360 minus 24.23. And those two answers are the two final answers. The first answer, the alpha, is not one of the answers. You are just using him now to get the other two, the two real answers. So 180 minus 24.23, right? I'm just making sure we have it correct here. I'm getting 155.77 degrees. And the next one is 360 minus 24.23. And I'm getting 335.77 degrees. Right? So let's try question 3. All right, so this question here, the only difference is I just put what? A fraction. So let's go through this question together again. So it only have one person to throw across, and that is sine. So at the point of throwing across the sine, as the sine falls to the other side, he changes the sign inverse. And he asks himself, hey, what number am I falling on? Is that positive or is that negative? And of course, 1/3 is clearly what? Positive, all right? So this note here does not apply. We don't have to ignore any negative sign. Can you all quickly find sine inverse of 1/3? You could use the fractions button on the calculator, right? Try your best not to round off 1/3 to 0.33333. You could just simply use the fractions button here. Second function, sine 1 ABC 3. And I'm getting 19.47. Remember, that first answer you get will always be who? Alpha, right? So, right, so it is 19.47, right? Try not to round it off, right, to 1 decimal place. We're trying to go to what? 2 decimal places. Everybody with me so far, right? One person said it was 270, but they just let me know in the chat that you finally saw the 19.47, right? Right. So we got our first answer. Now we ask ourselves, hey, this is a positive type of question because the sign that it was dropping on was positive and it involves sine. So it's a positive sign question. Where is sine positive? Which two quadrants, which two regions. Right, and a lot of people are getting it correct now. It's region 1 and region 2. Everybody is positive in region 1, and only sine is positive in region 2. So what are the formulas here? Well, whenever it's in region 1, alpha will be one of the answers. And to get the second answer, it's 180 minus how much? 19.47. So this is one of our answers. Get the second answer, please. 180 minus 19.47. And I am getting 160.53 degrees. That's our two answers. Right? Now, usually in the exam, right, the examiner will give you a range of answers. Like he will say that only use the, he will say something like this. This is how he might phrase it. This means the examiner is only accepting answers between 0 and 360 degrees. So if both answers are between 0 and 360, you keep them. If you get an answer that's larger than 360, I mean, even if you made no mistakes, and let's say your answer is more than 360, the examiner would ask you to ignore that particular answer. But in today's question, both answers are between 0 and 360. None of these answers larger than 360. So we keep in both of them. And the examiner will tell you which answers that he wants you to keep and which ones he wants you to discard. He will make it very, very, very clear. All right. All right. Now look at this question. This is a question. No, did I miss one? 4. No, we're on 5, right? So we're on question 5, right? Well, look at this question now. We still have to solve for theta. But we have a problem. In the other questions, it didn't have anything touching the sine, tan, or cosine here, right? It was just plain old what? Sine. So obviously, to solve for theta, it was super easy. We just have to throw across who? Sine. And of course, that made it really, really easy. However, we have this annoying -2 here, right? What do we have in between this -2 and the word sine? We have a secret something there. Well, what's the secret something? Multiply, correct. So this is really a secret multiply in between there. Here's the thing, right? Whenever we are deciding what type of question it is, right? We have to wait until it's time to throw across the sine, the tan, or the cosine. Only at that point in the question can we make a decision whether it's a positive type of question or a negative type of question. So let me show you a common mistake. A lot of people will look for the equal sign, right? Look for the equal sign, and they will look for the value after. And of course, the majority of people over here will see positive 0.85. So you know what people will do? They will automatically assume that this is a positive type of question involving who? Sine. So let me just assume that we made that mistake. If I assume this was a positive question involving sine, right? Which two regions would I choose by mistake? Well, what do you all think? Let's pretend we're making a mistake together. Which two regions would I choose if I assume this is a positive sine question? Right, you would choose 1 and 2 by mistake. And of course, you would use the formulas within those regions. But let's do the question the correct way now, right? Before we can even solve for theta, who do we have to throw across first? Don't we have to get rid of that -2? That -2 is a secret multiply. When he lands on the other side, he becomes what? A divide. So look at what happens now. We end up divided by -2. So we have sine theta, and let's divide this here. I need my calculator for that. 0.85 divided by -2. And if we do that, I'm going to keep all the decimal places. It's a nice decimal. We are getting negative 0.2, negative 0.425. We obviously are not finished with the question as yet. Now it's time to throw across the sign because we want to solve for theta. But look at it now. When the sign jumps across and it becomes sine inverse, what type of number is he landing on? He is landing on a negative number. So now we have to apply this rule here. At the point of throwing across sine, tan, or cosine, which we are, if it is negative, we ignore the negative, and it is negative. So we're going to put positive 0.425. Anybody want to work this out and send the answer for that? We're not finished. That's just piece at the start of the question. Second function, sine 0.425, and we're getting 25.15 degrees. Make sure you keep it to 2 decimal places at least. Right. Now, this is our alpha value. But at the point of throwing across the sign, that is where we make the decision whether it's a positive question or negative question. So this is actually a negative question involving sign. Where is sign negative? Which 2 regions is the correct region? Right, it's 3 and 4. So you have to use the formulas in regions 3 and 4. You're replacing alpha in both equations with what? 25.15. So you think you all can get the 2 answers here? Replace him with 25.15. Replace him with 25.15. Right? And those 2 answers will be the final answers. Right? 180 plus how much? 25.15. Right. Next one is 360 minus 25.15, which is 334.85 degrees. Right? So make sure you physically see those on your calculator. 6. All right, it looks a little bit more complicated. So since it's kind of complicated, obviously we can't make the decision at the moment whether it's positive or what? Negative. Who are we going to throw across first? The 1.2 or the -3? Don't let the tan theta get to you. If I wrote this like this, -3x plus 1.2 is equal to 0.85. Like I throw away the word tan theta and replace it with x. In a normal math class, you would have throw across him first. Some people said -3 first, right? You would actually throw across what? The positive 1.2 first. And then afterwards, you would throw across the -3. So he would be first and he would be what? Second. So do you all think you all could solve for tan theta? I mean, don't throw across tan theta as yet. Just try to get tan theta on one side and the 1.2 and the -3 on the other side. So take a few seconds and do that, right? And only after you do that, then I believe we'll be able to make a decision whether it's a positive type of question or a negative type of question. Okay. Let's see what's going on here, right? So the first person we're going to throw across is who? The positive 1.2. So we get -1.2. So I guess I can minus this. Let's see what we have. -3 tan theta 0.85 minus 1.2. And we're going to get what? Minus 0.35. But we're still not finished transposing. The minus 3 is what? A multiply. So throw across that multiply and we get what? A divide. So tan theta is equal, when you divide these two, 0.35 divided by 3. When you divide two negatives, you're going to get what? A positive, right? So we're going to get something like 0. Make sure you round it off properly, guys. I'm getting 0.12. Make sure, and some people might go to 3 decimal places, but remember the rule in class, we're trying to go to 2 at least, right? Now it's time to throw across the tan because we threw across everyone else already. So at the point of throwing across the tan, and the tan is landing on this side, he looks down and he says, hey, I'm going to land on a positive number. Where is tan positive? Which two regions would tan be positive? Right, sorta correct, Nikolai, Nicholas, plenty of people getting it correct, right? Anastasia, Leah, right. 1 and 3, right? But let's get the alpha value first, right? So we get tan inverse 0.12, right? So that means how much you get there? Second function, tan 0.12, I'm getting roughly 6.84 degrees, right? This is our alpha value. So it's in 1 and 3 we're going to visit. Well, in region 1, alpha is one of the answers. You already have a formula here. You just use alpha. And over here, we have to replace the alpha with 6.84 degrees. So theta 1 is 6.84 degrees. Send across theta 2. That's the one in region 3. Oh yeah, that easy. I now realize you can do that in your head. It's just 180 plus, yeah, that's right. So 186.84 degrees. Question 7. Right. Now, let me explain. Don't start this one as it, right? Let me help you out here. Trig functions are a little bit funny when it comes to brackets, right? Remember, if we have, let me just say we have x and theta plus pi on 2. Let me just say this came in an exam and you had regular boring x. I think by now everybody knows in maths class that whatever you have in the brackets will get multiplied by whatever is outside. So in normal maths, right, you would say x by theta, which is just what? X theta. And of course, the pi on 2 gets multiplied by x. So you'll get pi on 2x. The general rule is everyone in the brackets gets multiplied by what? Everyone outside the brackets. However, it doesn't work for trigs. Like if you put sine, tan, or cosine outside the brackets and the brackets come afterwards, you cannot say cos theta plus cos pi on 2. That's not allowed in maths. It just doesn't apply to what? Sine, tan, or cosine. And let's rewrite this question slightly different. Are these two questions the same? What do you all think? Are those two questions the same? The answer would be no, right? This one has brackets, meaning that both of these items at the same point in time belong to who? The cosine. They're being held hostage by cosine. In this one here, only the theta is being held hostage. This pi on 2, he's free. So if you had to throw him across, you could. You could just take across, take what? The pi on 2 and get negative pi on 2. I just saying, right? But in this one, you cannot move the theta. You cannot move the pi on 2 until you get rid of who? Cosine, okay? Also, sine, tan, and cosine were developed for angles. So that means everything inside this brackets is really angles. Theta is an angle and pi on 2 is an angle. However, you notice they did not give you the angle in degrees. In most exams, right, the majority of exams, in these types of questions, if they have to put an angle inside the brackets, for some reason, it is always put it in radians. Anybody wants to tell me how much is pi on 2? Because we're not accustomed with radians. We don't like radians. We didn't grow up with it. So I think we should just throw away the radians and replace it with the amount of degrees we're accustomed dealing with and growing up with. 90 degrees. So here's my suggestion. We put cos, open brackets, theta, plus 90 degrees. Doesn't this look a little bit less scary? Because we are accustomed seeing degrees. We don't care about radians, okay? So everyone rewrite the question. Like that, rewrite the question like that. All right, so now we still have to solve for theta. The aim of the question is to solve for who? Theta. Who do we have to throw across first? Are we going to throw across the cosine or the 90? Who do we have to throw across first? Well, I think I gave away that answer when I was rambling before. Right, we have to throw across the cosine because the 90 is being held hostage. We have to get rid of the hostage taker. I forget what it's called. All right, so we have to throw across cosine. But look at that. We are at the question, at the point in the question already where we are throwing across sine, tan, or cosine, in this case, cosine. Does this rule apply? No, because when we're throwing across the cosine and he's landing on this side, he will look down and see he's landing on a positive value. So he has no negative sign to ignore. So another thing now, at the point of throwing it across, we have to make a decision of what type of question it is. This is a positive question involving who? Cosine. Which two regions are we going to be paying attention to? Because we're at the point in the question where we have to make that decision. Where is cosine positive? It's two areas, right? It will always be two areas. You can't just send one. It's always going to be two areas. Well, we definitely have to choose area 1 because everybody is positive in area 1, including cosine, and 4. So it's 1 and 4. Great. So here's the thing. At the point of throwing across the cosine, we have to get our two answers before we proceed with the rest of the question. So do you think you can get the two answers for me? Forget about the 90 degrees. Don't even touch that 90 degrees until we get our two answers. So let's cosine inverse what now? Cosine inverse. So we have theta plus 90 degrees left on this side. And we have the cos inverse 0.85. But the thing about it, when we cos inverse 0.85, we're going to get two answers at the same point in time, right? So cos inverse, second function, cosine 0.85 is how much? I'm getting 31.79 degrees. This is our alpha value. So our first answer is 31.79 degrees. And of course, we have to replace alpha here with what? 31.79 degrees as well. 360 minus 31.79. And our second answer is 328.21 degrees. Let's make sure you're seeing that on the calculator. Okay. No problem, Jamal. Take care. Right. So we're not finished as yet, right? I'm running out of space. I want to go up here, right? So this is what we have so far. Theta plus 90 degrees, right? I'm writing it twice for a reason. Theta plus 90 degrees is equal to 31.79 degrees and 328.21 degrees. But we want to solve for theta. So to solve for theta in this equation, we take the positive 90 and we minus what? 90. And this one here, we throw across the positive 90 to get what? Minus 90 degrees. Okay? So you think you can get your final two answers for me? How much is theta 1? Well, this one will be theta 1 and he will be theta 2. So theta 1, solve that, and well, theta 2, solve this one. Right? It's okay to get negative angles, right? There's nothing wrong with a negative angle, well, in maths at least. First one is 31.79 minus 90. My first answer is minus 58.21 degrees. The next one is 238.21 degrees, right? I'll circle it in a different color, right? So this is our one answer, and this is our next answer, right? I'll put a little asterisk by it. So make sure you're physically seeing those things on your calculator. All right, so let's move on. All right, so this one here is it has an extra note underneath here, the note in yellow. Take down that note, right? And I will explain how to use that, right? This one will be a little troublesome, so I'll have to slow down the pace for this particular question. The main difference between this question and the other questions, you will notice that in the other questions, regardless of how complicated the question looked, didn't you only have theta, which means one theta? You never had two theta or three theta or four theta. Whenever you have a value touching the theta, well, other than one, like when it's 2, 3 or whatnot, the rules for it become a little bit different. You have a little extra few steps to do, but that's the yellow box here. Best way to do this is just to show you. So we want to solve for theta. The two of them are being held hostage by the cosine, right? So you can't touch the 2 as yet, which means you have to throw across the cosine. So when you throw across cosine and it's landing here, he says, whoa, whoa, wait up. That's a negative number I am falling on, which means we have to apply the rule in the green box. So this is what you are seeing for the time being. 2 theta, remember the cosine is being thrown across. Because it's negative, we ignore the negative sign. Could you all work this out for me quickly? Cos theta, sorry, cos inverse positive 0.45 because we are temporarily ignoring the negative sign. Okay, so let me try this. Second function, cosine 0.45. And I am getting 63.2, yes, 6 degrees, right? This is our alpha value. So our alpha value, right, is 63.26, right? But what kind of question is this really, right? Remember, we were just temporarily ignoring the negative sign. This is at the point of throwing across cosine. It was actually what? A negative cosine question. So which two regions are we going to be paying attention to? A negative cosine. Let's see if everybody gets this one correct. Think it through before you say. Think it through. Right. It cannot be 4, right? Because cosine is positive in region 4. Remember, in reality, it's a negative cosine question. So it's 2 and 3. Right. Before we move any further, right? You see, once we go to the chart, we get our 2 answers right away. So you all know what to do by now. You replace this alpha with what? 63.26 degrees, and you replace this alpha with 63.26 degrees. So get your 2 answers over there. I'll have to write it up here. Theta 1, theta 2. But I shouldn't call it theta 1 and theta 2 yet, right? Right. For this one here, I'm getting 148.37. That looking correct? Okay, somebody give him a wrong answer. I was stealing somebody's answer. Sorry, I won't do that again. All right, 180 minus 63.26. And I'm getting 116.74 degrees. And for the other one, I'm getting 180 plus 63.26 degrees. And I'm getting 243.26 degrees. Right. That is what we have so far, right? But remember, all of these things, right? These answers, all of them are equal to how much? 2. Remember, we have what we solved for so far was 2 theta. But before we move on, right? Pay attention to the yellow box here. You see these 2 answers. Before we divide by 2, what number do we have touching the theta? 2. How much is 1 less than that number? Well, 1 less than 2 is 1. 2 minus 1 is 1. So you see, to each of these answers, we have to add 360 ones. So I want you to add 360 to this and put the answer here. And to this one here, you add 360 as well. I'm just letting you know that if this was a 3 here, we would add 360 once and then 360 one more time. So add 360 once to all of them, right? I might have to do 2 examples on this one. So add 360 and you'll get how much? 116.74 plus 360. I'm getting how much? 476.74. And add 360 here as well. 243.63 plus 360. Make sure you're seeing these answers now. Right. So we end up with 4 possibilities, right? So remember, we want to solve for theta. So you know what you have to do now? You have to solve for theta, which means each of these answers you throw across and multiply to get what? A divide. But you have to add the 360 once before you do the final part of the question, which is divide by 2. So when you divide this, you'll get your final one answer, next final answer, next final answer. So you can probably call the final answers theta 1, theta 2, theta 3, theta 4. I'm getting 58.37. Somebody said I made a mistake. Yeah, I made a mistake here. 2, 6, my mistake. Right. Hopefully I won't make any mistakes from this point. And 603.26. And my last one is 301.63 degrees. Hopefully I didn't make any mistakes. Of course, feel free to point out if I do. All right, so for recording purposes, before we move on to question 9, I just want to make this question a little bit different. So crossing this out, right? So I could probably wipe it out. Right? Let me write back a fresh question there, right? Suppose you get this in the exam. Sine 3 theta is equal to 0.25, right? Now this 3 theta is being, I left out the brackets because if it's 3 theta, it means that both of them belong to the sine at the same point in time. So whenever you see 3 theta, we have to be on the lookout that most likely we're going to get 6 answers instead, because when it's 2 theta, we got 4 answers. And according to this note, how much times do you think we will be adding the 360? How much times? 2 times, right? 1 less, right? So the value here is 3. So we have to add the 360 twice to each answer. So let's do the easy part of the question. We throw across the sign because we have no choice because the 3 and the theta being held hostage. 3 theta is equal to sine inverse 0.25. But this is a positive type of question. So by now, everybody knows sine is positive where? Sine is positive in the second region and the first region. You can get the first 2 answers based on the region for me first, just the first 2 answers, and wait on me. Sine inverse 0.25. Right. And the alpha value is looking like what? 14.48. And what will be the second answer? Well, we know the first answer is 14.48. And the second answer will be 180 minus the 14.48. 180 minus 14.48. I am getting 165.52 degrees. Right. Now, here's the thing, right? Remember, we just found the 2 initial values. But those values, both of them are equal to 3 theta. So 3 theta is equal to 14.48. Well, we know that. And 3 theta at the same point in time is equal to 165.52. Now we know we have to divide him by 3 and him by 3. But wait a little bit. Before we start to divide, You see, to each of these answers here, we have to add 360 twice. So we're going to add 360 once and then add it again. And to this answer, we're going to add 360 once and then add it again. So we're going to end up with this. You're going to get two extra answers. Let me answer. I don't even know what answers, sorry. Add 360 to this. 14.48 plus 360. I'm getting 374.48. And then to this answer, add another 360. So you add 360 again. 3734.48. Make sure you're physically seeing it. To this one, add 360. 165.52. Add 360. We get 525.52. And then add 360 to this answer now. Make sure you're seeing it, right? And each of these answers are equal to 3 theta at the same point in time. So you have 6 answers existing at the same point in time that are equal to what? 3 theta. Now we can solve for theta. To solve for theta, we just have to divide all of them by what? 3. Throw across the 3, which is a multiply, you get a divide. And only after you divide all of them by 3, then you have your 6 answers, right? So you're going to have theta 1, theta 2, theta 3, theta 4, 5, and theta 6. Now, it's highly unlikely, right? Not highly, it's unlikely that you're going to get a 3 theta 1. I'm not saying it's impossible for the exam, right? But I still wanted, I know some of you were just really curious what would happen if you had 3 theta. It's not off the syllabus. It's just I haven't seen that come in the exam as yet. But you could be the unlucky people to get the 3 theta 1. Right? Right, so for recording purposes, these are the 6 answers that I got. All right, all right. So first things first, right? Well, we can't make a decision whether this is a positive question or a negative question. What else what other changes do you think, what change to this question do you think we should make? Well, what are we not accustomed seeing there? What's making the question look more complicated than it should be? Right, the radians, right? So go to your table. Pi on 6 is really how much degrees? Let's not work with pi on 6. That's just going to make us feel the question is hard. Right, so I'm going to erase that, right? I don't like how this pi on 6 is making me feel uncomfortable. So I'm going to erase that. In the exam, I'll physically rewrite the question, and then I will put what in its place? 30 degrees. The 2 pi minus 30 degrees are being held hostage by the sign. Who are we going to throw across first? Who is the first person? Because we're trying to solve for theta. So we're trying our best to get everybody on the other side. Who is first? The minus 2. Great. This minus 2 over here is a secret multiply. Throw him across. You get what? A divide. Divide these two. Minus 0.95 divided by minus 2. Right? Right? We're getting 3 decimal places. Keep them. It's 3. It's a nice decimal. So let's just keep it. I am getting sine 2 theta minus 30 degrees is equal to positive 0.475, right? Because you divide into negatives, you'll get what? A positive. Great. Now it's time to throw across the sign. So now it's time to make a decision of what kind of question is this. When the sign is being thrown across, he is falling down on what? A positive value. So which two quadrants are we going to choose? Where is sign positive? Right. And it's 1 and 2. So you think you all could get your first two answers for me and just wait on me? Just get your first two answers. By now, everyone should be able to do that part. Let's go in up here. I have some space, right? So when you sign inverse, because you're throwing across the sign, the 0.475, I believe you all are getting 28 point what? 36. So since it's region 1 and 2, we know one answer is definitely 28.36. And then we have to minus the answer from 180. So 180 minus 28.36. Our second answer is 151.64 degrees. Great. So make sure you're seeing that. But remember, those two answers are equal to what? 2 theta. So 2 theta minus 30 degrees is equal to how much? 28.36 degrees. And 2 theta minus 30 degrees is equal to how much? I had it somewhere. 151.64 degrees at the same point in time. But do not start to solve for theta as yet. How much times, notice this is 2 theta. How much times do we have to add 360 to each of these answers? Only once, according to the yellow note. So 2 theta minus 30 degrees is also equal to add 360 once, and put that answer here. And 2 theta minus 30 degrees to this value, add 360 once and put it here. All right, so when I add 360 once, I reach here. When I add 360 once, I got the 511. But we're not finished. We have to solve each of these equations now. For all of them, it's the same procedure. You throw across minus 30, you'll get positive 30 after you add it, divided by 2. So for all of them, you have to add 30, whatever you get, divided by 2. Add 30, divided by 2. Add 30, divided by 2. And that will give you theta 1, theta 2, theta 3, and theta 4. So I'll wait on those answers. Those are the answers I got so far. And for the last one is 270.82 degrees. So these are my 4 answers, right? And what I was saying about the 0 to 360, usually at the top of the question, right? Usually at the top of the question, the examiner will say, you'll see a statement like this. This means that when you get all the answers, you choose all the answers between 0 and 360. So do you think we will keep all the answers? Are all of those answers between 0 and 360? Yes, so in a case like that, we would what? Keep all the answers. But if you see this instead, at the top of the question, like the examiner only wants the answers between 0 and 80, which ones will we keep? I mean, we find all 4, right? But after we get all 4, then we go and choose the ones the examiner wants us to keep. All right, Anastasia, correct? No, not 1 and 2. I think we keep in 1 and 3, because 1 and 3 is in between 0 and 180. Oh, theta 2 is 200 and something. That's greater than 180. So only 1 and 3 fall within the region, right? So make sure in these questions, you look at the top of the question to see which answers to keep and which answers to discard, right? I believe I had made a video a couple years ago, right? If you go in the AdMaths classroom and you scroll down, let me look in the AdMaths classroom here, and scroll down. Let's look for trigonometry. Oh, look, trigonometry here. If you click on trigonometry, you will see video 1, video 2, and video 3. I believe video 1 went back through what we did today, but I used completely different examples. So if you want a second, like if you want to sharpen up on what was done today, you could probably go and look at video 1, and if you have time, video 2 and video 3. If you watch all 3 videos by next week, when I start to explain what I have to do next week, it's going to be super easy for you all. It's not mandatory, because I know some of you all say that you have term tests coming up and you need to revise for other topics. So it's not mandatory. For those who get tested on trigonometry, well, I really advise that you go through all 3 videos, so you'll get full marks in your exam. All right, guys, so I'm not going to keep you back too long. That's the end of class. And of course, I hope you understood what went on today. Take care. Have a good one.